Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you. Okay, so saya harap semuanya berada dalam keadaan baik, sihat dan sentiasa dalam perlindungan dan rahmat Allah Subhanahu Wa Taala, insya-Allah. So hari ini kita akan start our new chapter, which is chapter 5, application of the higher order differential equation, where in chapter 4 we have learned about the higher order differential equation, how to solve the higher order differential equation when we have two types of differential equation, which is homogeneous and non-homogeneous. Okay, we have a few methods such as the undetermined coefficient method, the superposition approach, the annihilator approach. You have the variation of parameter method, and we also learn about how to solve the Cauchy-Euler equation when it's involved the coefficient of the derivative which is including the variables. Okay, so how to solve Cauchy-Euler, kita ada beberapa method. Yang pertama kita belajar macam mana kita nak solve Cauchy-Euler yang homogeneous, and then kita belajar macam mana kita nak solve Cauchy-Euler yang non-homogeneous dengan menggunakan variation of parameter. And yang ketiga kita belajar macam mana kita nak transform our Cauchy-Euler equation into the differential equation with constant coefficient. Okay, so hari ini kita masuk dalam chapter 5, application untuk higher order differential equations. So when we are talking about higher order differential equations, it involves the differential equation with the derivative more than one. For example, second derivative, third derivative. Okay, so order of derivative is more than one, then we consider it as higher order differential equation. So as in first order differential equation that we learned before, we have learned one of the application of first order differential equation is the electric circuit, where in the electric circuit we divide it into two types, which is the RLE circuit and RCE circuit, where the RLE circuit is the resistant inductance electromotive force circuit, and also the resistant capacitance electromotive force circuits. Okay, so bila kita ada RLE means that is involve the inductor. Okay, so here we have the inductor in the electric circuit, and when we talking about the RCE, okay, resistant capacitor, it's involved the capacitor and also resistor. If resistant inductor means is resistor and also the inductor. Okay, so this is the application, or the application that we can the application we can apply first order differential equation. Okay, ada dua, RLE dan RCE. And in the second order differential equation, to apply the second order or higher order differential equation to the electric circuit, we have RLC, where it is a combination of RLE and RCE. If in the RLE circuit you only have the resistor and inductor, while on the RCE circuit you have the resistor and the capacitor, for RLC circuit we have all. We have resistor, we have the inductor, we have the capacitor, and also the source of voltage. Okay, energy source of voltage. So this will produce the higher order, or to be specified, the second order differential equation. Okay, so it's the difference between the system on in the first order and the system in the second order. In the first order, we only have a separate system, which is the resistor and inductor, and the other system is resistor and capacitor. Okay, both of these system will provide or will contribute to the first order differential equation. But in the second order differential equation, we will have the system of electric circuit that consists of or include all the component, which is the resistor, the inductor, and also the capacitor. The concept is still the same. Okay, so for revision, we have go through this before in our first order differential equation application. Okay, we have four components in our electric circuit. The first one is the resistor. Okay, so the symbol of resistor will be R and the unit will be ohm. So the amount of voltage across the resistor can be written as R multiplied by I, where I is the current. Okay, and then we have the second component, which is inductor. The symbol for inductor is L, and the unit for inductor is Henry. The amount of voltage across the inductor is L multiplied by di dt. okay, where L is a constant. Okay, R is a constant as well. L also is a constant. Okay, so di dt, I adalah current. And the third component, which is a capacitor, the symbol is C. The unit is farad or Faraday. Okay, and the amount of voltage across the capacitor is Q over C, where Q adalah Q adalah charge. Unitnya adalah coulomb. Okay, Q over C, Q adalah charge, unitnya adalah coulomb, C adalah constant. Okay, and E adalah electromotive force, simbolnya adalah volt, where electromotive force adalah the source of the energy. Okay, so it might be the battery or any other source of energy. Okay, so E is energy, symbol is volt. Okay, so Q adalah charge yang unitnya merupakan coulomb, and I adalah current, dan current also can be represented by dq dt. Okay, because when we have two symbol Q and I, means we have two different dependent variable. Okay, two different variable Q and I. Okay, so I also can be represented by dq over dt. The derivative of charge is current. Okay, so now the concept of electric circuit is same as before, where the amount of voltage supply, which is ET, okay, amount of voltage supply is equal to amount of voltage across inductor, let's say L, okay, plus with amount of voltage across resistor, let's say ER, and amount of voltage across capacitor EC. Okay, means that this is the beginning, how we can form our high order differential equation. So the amount of voltage supply is equal to amount of voltage across inductor plus amount of voltage across resistor plus amount of voltage across capacitor, where we know that amount of voltage across inductor can be written as L multiplied by di dt. So we write it L multiplied by di dt, plus with amount of voltage across resistor is Ri, plus with the amount of voltage across the capacitor is Q over C. So now we have our differential equation, but if you can see here, we have two variable. The first one is I, which is current, okay, and the Q, we see charge. We only want one variable only. Okay, and we know that I can be represented by dq over dt. So when we have I is equal to dq over dt, okay, means that you can substitute your I here with dq over dt. How about your di dt here? Di dt is the the derivative of I. So we can differentiate I to get di dt. And when you differentiate again this one, you will get your second derivative d square q dt square. Okay, therefore, you can substitute your di dt. You can substitute your di dt with d square q dt square and your I with dq dt. In return, you will get your equation as ET equal to L d square q dt square plus R dq dt plus 1 over C cube. Okay, and you can see this one is the system of higher order differential equation, and you have only one variable, which is Q. Okay, L, R, and C is a constant, so you only have one variable, which is Q. So this is how you get your higher order differential equation from your RLC circuit: resistor, capacitor, inductor, and capacitor circuit. Okay, where it's combined all the components in one electric circuits. Okay, where we know that amount of voltage supply is equal to the summation of all amount of voltage across the components. Okay, so here you get your second order differential equation. This is how you form or you derive your system of your electric circuits. Okay, so let's see the example here. Consider an RLC series circuit. So when we are talking about RLC, means that we have the second order application. Okay, with a resistance of 2 ohms. So resistance of 2 ohms means that your value of R is equal to 2. Okay, your R is equal to 2. And inductance of 1 Henry. So your L is equal to 1. A capacitance of 0.25 farad, your C is equal to 0.25. And an applied voltage of ET equal to 50 cos T. So your ET is 50 cos T. Find the equation of the charge. So means that it need at any time T. Find the equation of the charge. Charge is Q. So we need to find what is Q. QT means we need to solve our differential equation, because now we have d square q dt square. So solve for d square q, we will get q. Okay, solve for d square x, we will get x. So solve for d square q, we will get q. So now we need to solve our second order derivative. We know that the amount of voltage supply is equal to L d square q dt square. This one derived before. I have shown you how to derive this equation, how we get this equation from the electric circuit system. Okay, so 1 over CQ. Okay class, now you already have the value of L, R, C and also ET. So you just need to substitute. So what you will get is your L is equal to 1. So you only have 1 multiplied by d square q dt square, plus with R. R is 2 dq over dt, plus with C equal to 0.25, 1 over 0.25, Q equal to ET. So your ET is 50 cos T. Okay class, here you will have d square q dt square plus 2 dq over dt, plus this one is equal to 4q equal to 50 cos t. So if you see here, what you have is the non-homogeneous second order differential equation. So how to solve the non-homogeneous? To solve the non-homogeneous, we can use any method. Either you want to use the undetermined coefficient or you want to use the annihilator approach. Okay, so we can solve this one by finding what is our complementary solution YC first, and then we need to find what is our YP, and to get the solution we need to combine both. But you need to be careful, because now your equation is not in the term of Y. Your equation is in the term of Q. Therefore, what you need to find is not YC, YP, but it's QC and QP. And then we will combine both of these to get what is our Q in term of T. Okay, as our solution. So first we need to find what is our QC. Nak cari QC, kita transform this one to be homogeneous. So we will have d square q over dt square plus 2 dq over dt plus 4q equal to 0. And then we need to write it as our characteristic equation. So you will have lambda square plus 2 lambda plus 4 equal to 0. So you have lambda 2 lambda you cannot differentiate, you cannot factorize. I think we need to, let's check, b square minus 4ac. So b kita adalah 2, 4 minus 4, 1, 4, we will get 4 minus 16 negative 12. When is less than 0 means we have a complex root. So bila kita ada complex root, kita tak boleh solve guna factorize biasa, kita kena guna quadratic formula. So quadratic formula adalah negative b tambah tolak square root b square minus 4ac bahagi 2a. Okay, so our b is 2, so negative 2 plus minus square root B square. So 4 minus 4AC bahagi dengan 2A, 2 darab 1. So we have negative 2 plus minus dalam kurungan 4 tolak 16 adalah negatif 12 bahagi dengan 2. Okay, so you have here negatif 2 bahagi 2 tambah tolak. Punca kuasa 12 ni samalah dengan punca kuasa 4 3 bahagi 2i. Okay, sebab kita tukarkan negatif 2 kepada i. So kita dapat negatif 1 plus minus punca kuasa 4 adalah 2. 2 bahagi 2 habis. Punca kuasa 3i. Okay, so now you already know that kalau kita compare dengan alpha plus minus beta I, so we know that our alpha is equal to negative 1. Okay, and our beta is equal to set 3. Okay, so your QC, your general equation will be exponent alpha t, okay, multiply by C1 cos beta t plus C2 sin beta t. Okay, ini for complex root. Therefore, you have your QC equal to exponent. Alpha is negative, so negative t. C1 cos set 3t plus C2 sin set 3t. So, this one is your QC. Okay, so this one is your QC. So now what you need to find is QP. So nak cari QP, kita kena tengok kita punya Fx ataupun Ft here. Okay, so sama ada awak nak guna annihilator approach atau awak boleh terus sahaja menggunakan undetermined coefficient, which is kita terus tengok dekat table. Bila kita ada trigonometric function, kita punya YP akan in the form of A cos T plus B sin T. Am I right? Okay, A cos T plus B sin T, di mana A dan B tu adalah constant. So now kalau kita nak cari apa je nilai A dengan B, kita kena differentiate YP. So differentiate YP, kita akan dapat differentiate cos is negative sin. So we have negative A sin T. Differentiate sin adalah cos. So plus B cos T. Okay, differentiate lagi sekali YP double prime, differentiate sin cos, so negative A cos T, differentiate cos adalah sin, so negative B sin T. Okay, so bila awak dah ada YP prime, YP double prime, apa yang awak kena buat adalah gantikan dekat dalam awak punya equation. Okay, sebenarnya bukan YP, sorry, QP, silap lagi. Sebab kita punya variable sekarang adalah Q. So, semuanya adalah Q. Okay, QP, QP prime, QP double prime. Okay, so QP dengan Q adalah benda yang sama. So, sekarang kita ada double prime, ganti dekat double prime. Yang single prime, ganti dekat single prime. Yang Q, ganti dekat Q. Kita akan cari apa dia nilai A dan B. Okay, so kita gantikan QP double prime ni ke dalam equation. Awak akan dapat negative A cos T minus B sin T. Okay, tambah dengan 2 darab dengan negative A sin T plus B cos T. Okay, tambah dengan 4 darab dengan Q. So your Q is A cos T plus B sin T equal to 50 cos T. Equal to 50 cos T. Okay, so bila kita buka kurungan, kita tulis semula, kita ada negatif A cos T tolak B sin T. 2 darab dengan yang ini dapat negatif 2A sin T. 2 darab dengan this one, awak akan dapat plus 2B cos T. 4 darab sini dapat plus 4A cos T. 4 darab sini plus 4B sin T equal to 50 cos T. Okay, and then kita cuba tengok yang mana kita boleh simplify. Kalau awak tengok yang ini cos T, yang ini pun cos T, yang ini pun cos T. Okay, so kita ada dekat sini negatif A tambah 2B tambah 4A. So negatif A tambah 4A adalah 3A. So 3A tambah dengan 2B. So boleh tulis kat bawah ni 3A tambah 2B cos T. Okay, lepas tu kita tengok another one. Another one ni kita ada sin T dengan sin T. Okay, so tengok dia punya coefficient negatif B tolak dengan 2A tambah dengan 4B. So negatif B tambah 4B 3B, 3B tolak 2A. So we have here plus 3B minus 2A sin T equal to 50 cos T. Okay, so kalau saya tulis nak bagi tak pening, okay, so yang ini tadi adalah YC, yang tadi adalah YC kita. Okay, ni YC, jangan tersilap ni YC. So sekarang yang sebelah ni kita nak cari YP. Yang ni kita nak cari QP. Okay, so kalau saya tulis yang ini selari, dia akan jadi macam ni. 3A tambah 2B cos T tambah dengan 3B tolak 2A sin T sama dengan 50 cos T. So we can compare left hand side and right hand side. So cos compare dengan cos. So tengok sini cos compare dengan cos. So kita akan dapat 3A tambah 2B sama dengan 50. Equation yang pertama. Okay, and then kita dapat equation yang kedua ni sin. Tapi dekat belah sini tak ada sin. Maksudnya yang ini is equal to 0. So 3B tolak 2A sama dengan kosong. Okay, so kita dapat kita punya simultaneous equation. So kita boleh solve kita punya equation. Kita akan dapat sini katakanlah 3A tambah 2B sama dengan 50. Sini negatif 2A plus 3B equal to 0. Okay, so awak boleh guna calculator ataupun awak boleh guna secara manual. Kalau guna secara manual, saya darabkan semua ni dengan 2. Yang ini saya darabkan dengan 3. So saya akan dapat 9A tambah 6B sama dengan 150. Equation kedua saya dapat negatif 4A tambah 6B sama dengan kosong. So kita boleh hapuskan B dengan operasi tolak. So 6B tolak 6B habis. Tolak dengan tolak tambah 9A tambah 4A 13A sama dengan 150. So A sama dengan 150 per 13. Okay, so dapat A sama dengan 150 per 13. Kita cari pula nilai B. So nak cari nilai B, kita masukkan sahaja dalam equation kita. 3 darab 150 per 13 tambah 2B sama dengan 50. So kalau awak kira, awak akan dapat awak punya B sama dengan 100 per 13. Boleh kira. Okay, so awak dah dapat A awak dah dapat B awak boleh masukkan nilai A dan B dalam kita punya QP because kita nak QP kita apa. Okay, so QP kita A cos T plus B sin T. Therefore, our QP will be A cos T 150 per 13 cos T plus 100 over 13 sin T. So inilah awak punya QP. So awak dah ada QP, awak dah ada QC, awak hanya kena combine untuk awak dapat apa awak punya Q. Okay, yang ini macam kita solve sebelum ni lah. So kita punya Q, ni QC. Okay, kita combine. Untuk dapat Q in term of T, kita combinekan QC dan QP. So you will have 150 over 13 cos T plus 100 over 13 sin T. So this one is the solution, the current yang you kena cari. Bukan the current, the charge. Okay, the charge yang dia minta QT. Okay, just solve a non-homogeneous second order differential equation. So you dapat you punya persamaan. Kalau dia bagi tahu initial condition, contohnya dia kata initially current equal to 0. So kita bolehlah masukkan dia punya condition untuk kita cari kita punya constant C1 dan constant C2. Tapi untuk case ni dia tak bagi, so kita just bagi dia general solution lah. Okay.